All right. Yeah. Let's go. Wait, no, BumperCoins bot. So last time I wrote something called some untested work on net.getPolicy and value. So let's kind of continue that, I guess. Let's open up Firefox, look at the whiteboard. So then, yeah, so right now we're kind of like in this part, we're kind of extracting the policy, right? So a 0, 1, 2, 3, 4, and so forth, like 8 cardinal directions, that's what we chose. Oh, okay, whatever. Oh yeah, so let's just, let's get started. That's yes. Yeah, see, num move to Earth is 8, okay, good. In fact, let's actually look at usage of it. So yeah, as we see here, get policy and value, right? This is the function we're kind of working with. Like this function here, we're working with that, right? Okay, so then basically like we have to do this to do get move velocity from movedir. So like, so let's consider this. We have a move ID, right? And a magnitude. Okay, so let's open up shared constants just to see that. Yeah, let's just look at shared constants. Shared constants. Actually, I want to look at BumperCoins to see how the apply move actually works. Is the magnitude 0.4 times max velocity? Actually, no, let me look at shared constants. Okay, so then launch max velocity is fixed point and then like this, right? You know what I'm gonna do something differently. Let's or actually let me get status. Let me CD into BumperCoins, or actually let me just look at how BumperCoins does move as again. BumperCoins. What's it called? Shared. No, and let me see how it does it. Server or client side, like action state manager. So the front end, a client action state manager. Let me see like handle up, action state manager. Huh? Okay, so right here we have handle up. So this is the coin pressed intermediate action state, right? This means we have like one clicked on a coin and then we're currently dragging it, right? So like this kind of stores like where we're dragging it. That's the kind of radius of max, like 4 squares. Like if you have a coin centered on like x comma y, and then like you're clicking on a point like of magnitude like past 4, it's a full launch. So everything's kind of like it's a clamp, right? Like if you kind of flick it any further, it's not going to change the launch velocity. So in handle up, right, like basically what we do is we have a like the mouse is on a x and y, right? Now these x and y are not like the actual pixels in the canvas. These are actually have been normalized so that they match. They've been converted, scaled. Yeah, they've been scaled. Like when I was mentioning discretization factor in terms of like kind of like discretizing the game state, and we have discretization factor of 1, and I explored 1 and 3 previously. I was actually thinking of calling it scaling factor as well, because like it's like kind of, because what it's really doing is it's like kind of a scale, right? But I call it discretization because like that's kind of like the bigger picture view, right? Not the kind of immediate view. But anyways, like it's doing a scaling operation, but it's doing it for the purpose of discretization. Just some semantics, I guess. But anyway, so like here's x, y. And then what we're doing is like we look at the center of the coin, right? and we compute the dx and the dy, the deltas, and then we just use Pythagorean theorem, a squared plus b squared equals c squared. So we solve for c, the hypot, which is the hypotenuse, which is the distance. And then what we do is we compute a normal vector from that. It's the normal vector. So the normal vector, basically, we can compute by trig operations, right? When it comes to like these directions. So we need a normal vector. So this computes a normal vector. That's great because angle, like a sine angle and a cosine angle, like those two components are like they do form a normal vector because you know that sine theta plus cosine theta equals 1, right? That's a trig identity. I mean, that's kind of obvious. You just draw a unit circle, right? Like no big deal, just a unit circle, like simple polar, like, yeah, just draw a unit circle to prove that. And then the extent is like the distance. So like basically here's the clamp operation. We take the distance and we kind of divide by the max launch radius, which is a 4. So like even if you do like 5 grid cells or 6 grid cells, they still like kind of give you 1. Like we're clamping down. So like 1 is the maximum we can get because we're minning on that. Right? Fair enough. And then what we do here, this is the code which I wanted to see, right? We take the extent, and then in our code, the extent is going to be 0.4. That is the thing. So extent times fixed point dot to number, this thing, times dx norm and dy norm. So these two lines are crucial. So like, yeah, extent. So that's what we want to see. So let's just copy that. Or sorry about that. Not Command A, Control A to go to the beginning of the currently entering the whatever. Yeah, just Control A to go to the beginning of this line, and then vim that.ts and this, right? Perfect. So we're searching for extent. Not here. We want to see the handle up. Actually, technically, we could see it there too. They do the exact same logic. Bit of a copy-paste thing. Could have extracted. Anyways. So yeah, so I'm just going to take these two lines here, kind of yank them. And then let's just go to the bottom of the file. And let us just kind of put this in a comment block. Like that. Okay, good. Okay, so basically, like, where dx norm and where the vector dx norm, dy norm, or the velocity vector dx dy norm is a normal vector will be yeah, it was a normal vector. That means normal vector means magnitude of 1, and the extent will be hard coded to a 0.4. Yeah, extent will be hard coded to 0.4, right? 0.4 of the max velocity. And as for the king multiplier, that is handled in apply move, if you recall that. So okay, so now we'd like, these are just kind of like, so we need theta, and then dx would be cosine theta, dy would be actually not sine theta, but negative sine theta, because in the canvas, like when you think about it, not canvas, and like just like the 2D, like the representation, the y goes down. Like the row index, we don't start from, like we start from the top left. So like not from the bottom left, like in math where the origin's at 0, 0. But here our origin 0, 0 is kind of, okay, technically it's 0, 0, but like it's from the top left, like inner game state discretization. Like when we increase y, then like it kind of goes, never mind. I could just like kind of show it visually, right? So like my mouse would be, so like as I go from left to right, that increases x, like the x coordinates. But then as I go down, the y coordinates actually increase. Like that's like the 0th row, 1st row, 2nd row, and like it goes down. So like it's a bit unintuitive, but yeah, that's how it works for many things in graphics. But anyways, so let's get started. So then yeah, I might just only do this actually, maybe like try to test it out. So get move velocity from move dir. So let's just consider a dir, right? well, let's say 1 minute left. Let's just refresh. I feel like want a clean slate. Yeah, let's just create a new one. Okay, so let's have this our origin. We have like 1 here. 4 of these guys. Okay, so then we have like 0, 1, ... 7, right? So let's consider this 1 right here, right? So then what is the angle theta? What is this theta, right? So what would theta be? Well, so basically our num_ders is 8, right? So then 1 full, like 2 pi is 360, right? Like 2 pi is to the whole thing, right? So you have 2 pi, and then we're kind of chopping that into 8s over num_ders. So theta equals 2 pi over num num_ders times the move ID, right? Times move ID. Because like it's just kind of linear, like 1 theta, 2 theta, 3 theta, 4 theta, like when move ID is 1, right? Like times 1, right? So like if you're doing it for 1, like you get like pi over 4 equals pi over 4, right? And that is correct. Because 45 degrees is pi over 4, right? Like that's just math. So yeah, so this checks out, right? That's pi over 4, and then for 2, right? For 2, it's just like we're doubling it, so it scales linearly. That's why I'm multiplying by move ID, right? We triple it, like we go pi over 4 times 3, that would give us 3. Pi over 4 times 4, well, that gives us pi, perfect, and so forth. So we know how this formula works, right? So this is our formula for theta, right? Theta is that times the move ID, or dir ID. I think move ID. Move ID, dir ID, same thing. Move ID. ID. Okay. JavaScript math pi. Okay, math.py. Copy that. Paste it. Venus, what the hell? Math.py, okay, good. So now let's let theta. Sorry. Let theta, which is a number, equals to what? To 2 times, so 2 times, and paste that, math.py, divided by the number of ders, which is 8, divided by, let's go to the top, num_ders, 128. So 2 pi divided by that, and then times, let's just kind of do it in the right. Move ID times, yeah, let's just kind of like separate the numerators from the denominators. So move ID times 2 pi over 8. So that's theta, right? So let's just kind of solve it for the case of theta equals 1. Everything else will just generalize for free, I'm pretty sure. So let's check it out. So right now we have pi over 4, right? So right now, like, we're kind of like, we have like, sorry. So this is our kind of x-axis. Like, we have this, right? So then that means like, so like, what's the velocity, right? Like, what's the normal? Like, we want like this normal vector, right? Like we want this vector here. So what are the components of this vector? This is a unit vector in pi over 4, right? So then if this is theta, right? Then the x component is simply cosine theta, and the y component is sine theta, but we have to flip the sign. Sine theta, right? Wait, do we have to flip the sign? Okay, well, let's just do it for, let's just consider this case for direction 2, right? So then here, this kind of direction is a 0, 1, right? Like cosine of pi over 2, the x component is just 0, and then it's 1. But then the desired velocity, if you have a coin here and we're shooting it that direction, right? Then like if its y is at y1 and then it's going to y2, then it must be the case that y2 is less than y1, because our reference point like y increases this way. Like y starts from 0 at the very top and kind of goes down. That means like that's kind of like y kind of goes this way. So like if you're fighting against the y field, then we're doing work against gravity, so like the sign gets flipped, right? Like if this is like if we're at 1, or like if we're at 2 and then we kind of land on 1, because like to going up means that we're seeing so going down means we're seeing larger numbers, going up means we're seeing smaller numbers. That's it. So y2 is less than y1. Therefore the delta y is like y2 minus y1 is y2 minus y1, but then we know that y2 is less than y1, so that means the sign is negative. So we want to impart a negative component to the velocity to get it to like go up, because of like So okay, so that's kind of like the main thing. And then we have the same thing where cosine squared theta, like c squared theta plus sine squared theta equals 1. And like even if you were to like flip the signs, the squares kind of like, it still applies. Like obviously that changes nothing. So that's a fair operation. So then so now what we do is we so let's let, what's that thing called? Dx norm. Yeah, let's copy that. YB, let dx norm number equal to math.cosine pi cosine in radians. Okay, good. Yeah, radians. Perfect. We're working in radians. Copy. Let's copy that. So math.cosine theta is in radians. And then same thing but for y. dy norm math.sine, obviously. Make sure that's true. Yeah, math.sin, sine, yep. Math.sine theta. So then dvx dvy equals fixed point dot 2. Okay, this seems very dumb. Let's actually like, instead of like doing fixed coin dot, wait, no, never mind. Sorry. Let's just let's kind of open the other one. Rather than convert it to a number, right? What we can do, just I should have done this in the actual game code in the client side, is we can just take this number here, right? Let's just take this number, right? Let's just kind of take that number here. Oh wait, I see the problem. Never mind. No, we have to do that. Right? No, sorry. We actually have to convert it to number because or I should define it in shared constants. I should have like both the number and the fixed point kind of approximation of it. Okay, so then that's all. So then we have the extent. Let extent number equals 0.4. Right, that's the extent. So dvx, dvy is that, right? From number just like that, right? I think we're done. Vx and vy. So we have this normal vector, like we have the normal vector, like dx norm comma dy norm, and then we're basically scaling it by the exact same thing. Like whatever we scale a normal vector by, like if you multiply all components of a normal vector by like k, then the new magnitude becomes k. So our new magnitude becomes the extent is 0.4 times this max velocity, which is exactly what we wanted to do. So I think this is an order. And then, oh wait, I have to negate it. I have to make this negative. That's crucial. That's very crucial. -1 times that. Or actually, I think I have a negate operation. Never mind, that's fine. Yeah, let's just be kind of proper about it. Actually, no, never mind. Just like that. Okay, does this look good? I think this is correct. So now I kind of want to test it. So what I should do? Actually, I'm gonna use the restroom first, and then get back to this. Well, let me make sure that I'm actually recording. Let's shrink this down and wiggle it. Okay, good. So it is recording. I should have done that in the start. Right. Just drink some water. Make sure they're still running. Okay, good. Alright, I'm back. Right. Okay. Right. So I said I was gonna start doing some tests, I guess. Actually, for now, let's just kind of let's just save everything for now. Or actually, first we have to check if it compiles. Ah, there is an error. You have to import shared constants. Like this. Now let's test it. Let's test it compiled. Okay, good. Get status. Let's just add everything that we have so far. Yeah, so all we did was we added the import, and then we we removed the line that says to do the trig and return 0, 0. Instead, we're just kind of extracting theta and just kind of doing it. In fact, we could inline the whole thing. Like, we could compute theta, and then what we could do is, like, we could kind of, because like all these variables are only being used exactly once, except extent and theta, right? Like, theta is being used twice here, and like extent is being used. Anyways, well, whatever. This is kind of step by step. It's not a big deal. Okay, so then we have like our velocities, right? So now that you have the velocities and stuff, let's see. So let's test it. I feel like I'm going to let's close that. I think I'm just gonna have like let 1 be our guinea pig, our move direction of 1, or pi over 4, or 45 degrees, pi over 4 radians to be kind of our guinea pig. So let's just kind of check it out, right? So like we have this coin at 0, 1, 2, 3, 4, 5, 6, 7. So its row index is 7. 0, 1, 2, 3, 4, 5, 6, 7. Which means you have 7 above and 7 below. And then 7, row index, column index 1. That's where the coin is snapped to. And let's just move it, like apply the move at that. So let's actually kind of test it out. Status. TS. Actually, let's just kind of open up net.ts and gamestate.ts. We're going to test okay, so right here we have these two lines that actually don't, so let's actually delete those two and bring them to the bottom. Sorry about that, I undid everything. Let's just take these 3 lines here, delete them, go to the end of the file, move them down here. Testing out some stuff, namely launching. Let's just launch the king coin. The reason I'm saying king coin P1 king coin from starting state with all 8 movers. Let's start off with 1. So this also tests game state dot no need for it to be capital, whatever, game state dot apply move, right? Like if you look at, we're gonna like kind of do apply move, this thing right here, right? Like that. We're gonna test this function too. Yeah, see, here's a time. The velocity multiplier kind of is on top of everything. So okay, let us do that. Oh wait, hold on. Hold on, just one moment. Coin is the match on the move. Yep, yeah, get coins for player does that, filters it out for us. Okay, good, yeah, perfect. So then everything seems to be correct. So let's get started. Oh, wait, no. So in convert game state to model input, let's, sorry about that. Let's actually bring back this print statement, right? Let's kind of print out, like, kind of, yes, I will undo these changes, but like, console.log image stack of 0. So then console.log initial king coin discretized location, like that. Actually, at first, or wait, no, they have to get the king coin. Let king or p1 king coin ID string equals to for let coin of game state dot coins if coin dot is king and coin dot is p1, or what's it called? Yeah, c dot is p1. Let's just kind of copy that. Wait, that is what I had. Coin dot is p1. Equals coin dot ID. Okay. Great. Oh yeah, first thing first, let's just kind of remove this out. And actually no, sorry about that. Let's bring that back there. And then console.log let's print out the coin. Okay, so that's the JSON. Initial king coin discretized location. Okay, good. So now what we want to do is we want to actually like kind of do let move or move for p1 or just move equals to okay, so in this thing, get move velocity from move dir, I guess that's what we're testing. How is that used again? Get move velocity from move dir. I know it's used somewhere in here, right? Exactly this. Line 99. I copy these two lines, go back here, and I just kind of paste that. So let move velocity, fixed point, equals get move, and let's fine, okay, fine. So right now let's set let's let move ID number equal to a 1. We're testing it. We'll test it for all of them. Don't worry. We're just testing it for this one circled, but we will test everything, right? So then what we're gonna do now is like we're going to console.log move velocity plus like that. What else? Then we generate the move with not coin ID, but this we have the king P1 king coin ID. And the move ID is there. The move velocity of 0 and the move velocity of 1. So that means like this thing returns like these velocities in the form Vx, Vy. So X first, then Y, which is actually the opposite of this one that returns Y and X because row and column. But anyway, so the point is that just X and Y. So now let's actually do like the next file. Apply move. So apply move takes in the move and then the this thing. I'm just pass it undefined for now. Game state dot apply move, which is the move itself. And then new prev game state is what? We find game state dot clone, whatever, just like we'll do in MC Monte Carlo tree search. Just like that. And then do the same thing. And then for like the new one, what we're doing is we're wait, no, sorry, it's the other way around. Let's delete that one. Let's just clone the game state, right? Clone the game state so we don't destroy that. Or sorry, let next game state equals just like that. And now from all these coins, just gamestate.coins, console.log, new king coin raw, and let's kind of do these two things. But new instead of initial becomes new. Let's make these all anyway. So initial and then new king coin's precise location is that, but for wrong game state. Okay, so just like this, right? Let's see if that works. Clear tsc net. Nice, no errors. Node net.js. It's a lot of stuff. Node net.js. So initially what happens is we have this and this. Okay, never mind. How is sync string substitution again? Interpolation. So backtick. Let's copy that. So like this. No, initial king coin. Initial king coin X. Comma coin Y. So fixed point dot to number coin dot X. Same thing for there. But make that Y. Just like that. So initial king coin. Because like if we saw the output, it was in fixed point form. So we needed. I just wanted to like kind of make it to that form. So now instead of new, we just kind of go here, paste that, and then delete these logging coins because we only care about the coordinates, to be honest. Okay. Okay, good. Now let's just run this. Clear, compile it, and run it. Okay, so initially we're at 1.5, 7.5. So let's check that. 7.5. So 0, 1, 2, 3, 4, 5, 6, 7, and 0.5. So like that's the center, like that's the x coordinate. The y coordinate is 1.5, so like 1 point. Remember, we actually moved it to here. 1.5, so that's correct. Initially it is there. And then if we kind of look at the thing, we have 7 0 rows, 1, 2, 3, 4, 5, 6, 7, and then 0, 1. So that means that that's correct. And then we're launching it, and now we're going to like take this coin, like launch it like this way a bit, 45 degrees. So like there. So let's see what happens. So now the move velocity O. Okay, so let's kind of, that's a bad print. Let's actually kind of go back. I want to see this discretization actually. Let me just get to it. So then 1 0 2 3 4 5 6 0 0 1, right? So it's changed. Previous one had 7 zeros and then 0 1, but now it's like 1 to top and 1 there. So it shows change, right? Like zeros, like 1 2 3 4 5 6, right? So only 6 zeros, and on the 7th one, it's the third. So it's like 1 row 0, 2, 3, 4, 5, 6, and then 0, 1, 2. So the coin basically goes from here to here. Like we can see it kind of move like the king in chess. Like it just moved 1 square to the diagonal, or bishop, or queen, but king because 1 is the max can move. But anyways, we saw that, right? And then we can look at the actual, oh, that's it. So now what I want to do, yeah, and now look at the new location. The Y is 6.4. It used to be 7.5, now it's 6.4. So like 0, 1, 2, 3, 4, 5, 6. Wait, no, 0, 1, 2, 3, 4, 5, 6.4. So that's the X coordinate. I mean, sorry, that's the Y, that's the Y coordinate. The Y coordinate is 6.4, and then X coordinate's like 2.6. So 0, 1, 2.6. So here's the center of the new coin. So it used to be here, but now it's there, and like the discretization showed that. And I just wanted to show the move for a good measure, because right now we have move velocity as object comma object. Let's actually change that to let's actually like print it out using string interpolation again. So yeah, I'm pretty happy that this kind of works so far. So then what we have is string interpolation. Move velocity. So you make that a backtick. Move velocity of x, and make this a backtick. And then kind of delete everything there. So move velocity x is and then the dollar sign and like that. So that's kind of copy what I did for coin. Fixed point dot to number the velocity of x, which is this guy. Sorry, this guy. Move velocity. Dot and then dot f0, right? Because it returns move velocity in the form vx and vy. Wait, what did I just do? Oops, okay, fine, whatever. And then same thing but for y. Move vela, or never mind. Velocity x. Make that 1 for y to get the second one. Just like that. I think that looks good. So let's kind of see it again. Clear, compile, note it. Okay, so same thing. Let's just look at the move. So now we see how it's like 0.05 and then negative 0.05, right? And then what did I say? That its magnitude for this vector should be 0.4 times maximal velocity shared, which is like what? Less shared TS, right? So then its launch max velocity is 0.178 times 0.4. So 0.178 times 0.4 is this, 0.712, right? So now what we have is we want this squared plus this squared to equal this thing squared. So this thing, let's take that 0.272 times 0.0712 is 0.00506. So this is our target, right? Let's open up a new tab and let's take this thing. That's clearly that, but negative. So let's kind of copy that. Kind of go here. Squared plus the whole thing times 2 is 0.00506. 0.00506. So 3 zeros and a 5, like including leading. So like leading, like 3 zeros including leading. 3 zeros including leading. 50679. 5069. Okay, so it starts to differ by a little bit. But again, we're dealing with like fixed points. So it's like 506, about 507. 507. Okay, yeah, that's pretty good. So we had it work for move ID 1. Now let's try it. So like basically like with like by doing move ID 1, we've kind of tested out that like the 45 degrees, like the pi's over 4, like n pi over 4 kind of n pi over 4 definitely works, because everything else is like we've kind of like proved the diagonals, like we've done all the diags, right? So we have now kind of validated all of those. But just for good measure, like this is kind of like a like positive negative. Let's just kind of like do like, so right now like both the like the x and the y are, never mind. Let's just like kind of do it for yeah, I feel like the pi's over 4s are done. But now let's try a vertical one. So let's kind of like make it go 1 up, right? So that's move direction 2. Or actually, let's keep it super simple and just make it go 1 to the right. So now let's try move direction of 0, right? Let's see how that goes. Get status. Again, like these diffs, I'm gonna just like stash these diffs, because like these diffs are kind of more for testing. Like this is just for my own satisfaction, just to make sure that these changes that were in the modified are correct. Okay, so let's kind of go back and start like testing other directions. Actually, let me just test all the directions. So we've done 1. Now let's just do 0. Rewrite that and quit it. Okay, clear. And then let's just run everything. Compile and then run. Okay, so now we're kind of like launching it like this direction. So we expect it to like go a bit to the right. So yeah, let's kind of take it from the top. 7.5, correct. 1.5. So we don't really care about we only care about like the 1.5 and like see how that changes, right? So let's skip over this. No need to talk about that. We know it's 7 zeros. It's like 7 zeros and like 001, right? Now what's gonna happen is 7 zeros and 001, right? 1, 2, 3, 4, 5, 6, 7. Oh, 0001. So basically jump 2. Whereas like, yeah, okay, so like basically like if you kind of like look at like, if you kind of like draw it out, like if you have like, let's say like this is your coin like right here, right? So like from here to here, like it was here first and it kind of goes here with move index 1, but then it kind of goes here with move index 0, like here, right? So it's like we can kind of see the coin like discretized move. So in fact, here's kind of how it looks. Like you have a coin here, and like this will be kind of like move index of 0. And I predict, and like this will be kind of move index of 1, and that would be of 2, and that would be of 3, and we basically form a diagonal or like a diamond or like a rotated box. So like here's kind of like what I believe now is going to be like the changes like from here, like the direction is discretized. So we're getting a good spread. I kind of like that. So I guess like the 30 ticks, which was like 0.4 times max strength, is 30 ticks, and 30 ticks was a good amount because like after letting the game stay advance 30 ticks, we can actually like see the changes. So that shows some progression, and I think that's very nice. So that's pretty good. Because again, everything is abstractions. Like we're not actually like creating a real time, like it's not continuous spaces of like games like action space and state space, but we're discretizing a lot of stuff. So we're showing progression, right? So that's pretty nice. That something's happening when you make a move and you can visually see it. But anyways, I digress. So then initially, so I kind of skipped, I skipped these two. So move velocity y is 0, which is correct because when we're launching in direction 0, there is no y component. It's only an x component, which is positive. So 3.05. So what is 3.05? So we want 3.05 squared, or sorry, we want 0.07 squared to be 0.00509, I think. Let's take this thing here, copy that, and just square it, just for my own satisfaction. So we want it to like be this 0.00509 or 507. So let's take this thing and then square it. Yeah, correct. 0.005069. 0.005069 or 7. So that's perfect. So this also works. So we've now tested directions 0 and 1. So this direction looks good. That looks good. And then 2, 3, 4. Actually, yeah, I think I'll just test all of them and end the stream. So I've done 0 and 1. Let's just do 2. Okay, so now we're testing move direction 2, which is directly north, directly up. So then we know the initial one. We've already seen these. No big deal. So let's do a prediction. From 7.5, I'm going to say 5.5 or 5 point something because it's going to go like up by 2-ish, right? So let's see. So it's 5 is like kind of negative. So then like it's 5 point, wait, what did I say prediction? I said 5.5 because it goes 2 in the discretization. I was going to say like kind of like, it kind of goes like 1, 2, but then that's like, but actually goes from 7.5 to what, like 6, I think? Yeah, around 6. So only goes 1.5, but discretization kind of rounds that up to 2. But okay, that's okay. I'm fine with that. So 7.5, and then we kind of move a little bit. And how much do we move? Well, this. So 5.9 plus 0.07 is what? 5.94? I just want to make sure I'm not insane. Oh, we have to do it 30 times. Yeah, no, what am I doing? Sorry, that's not how it works. So new one is like 5 points. So we're basically kind of going negative, which means we're going up. We're reversing the y-axis because the y-axis is reversed. So 5.9, and then the new thing should be what? Let's predict. Instead of having 7 rows of zeros, we should only have 5 rows of zeros and 0.0 and then second one because x is unchanged, right? So basically what I'm saying is this one should kind of skip like here and then here. So like this one should be 1. So instead of 7 rows of zeros, we should only have 5, right? Like 1, 2, 3, 4, 5. So let's check our prediction. 1, 2, 3, 4, 5, and then 0, 1, right? So that's good. Okay, so that looks correct. So we have now tested, so we have tested 2. Then 3, 4, 5, 6, 7. Okay, so now let's test 3. So we're like halfway there, almost. Clear, compile, run. Okay. Okay, this looks kind of weird. I'll take it. So then we know the initials already. We can actually skip the initials. Just like so this one, 1.5, 7.5. Okay, we know it's up. We know how that looks. So then what happens? Okay, so this 0.05 we've already seen before, so it's kind of like, yeah, we trust it. Then the new location is 0.56, so it's kind of shifted a bit to left from 1.5 to like a little bit to left. And then a 6.4. Where did it start again? It started here, so it can't really go 2, so it just becomes the first one. Wait, why is this point 0.96? There should be a 1. Wait, what? Oh, I see what happened. Right, so like it was here, right? And it tried to go, but it hit the wall and bounced back. And that's why its health became a 0.96. You see that? The health actually kind of got hit. Oh, that's pretty cool. Okay, but let's actually change the starting location to stop that from happening next time. But for now, that's pretty cool. Like, you see how it changes. So it's not always 1s and 0s. It's actually the health of the coin. So the coin went left, it hit the wall and bounced back. I guess I should kind of show it like this way because my right is your left. So like it hits the wall, it bounces back. Okay, so then that somewhat makes sense. And then it also kind of goes, it went up a bit. From 7.5, it goes up to 6.4. So 0, so 1, 2, 3, 4, 5, 6. So then, yeah, it kind of reflects that only 6 rows of zeros above and not 7. So it has been pushed up a bit too. Basically, like, from this one, it became that one. And then it can't go beyond because it hits the wall and bounces off. But one thing I want to do now, or actually, okay, yeah, that looks good. But one thing, yeah, so like its X kind of hit the wall. It can't go negative. So one thing I want to do is actually kind of go to our game state, gamestate.ts, and let's actually take the initial coin, and rather than starting it off at 1.5, let's start it off at like 2.5, just so that it doesn't hit the wall. So it'll still be like, I just want to like see like where it lands. I don't want it to like hit the wall. So let's try it again. Again, these all changes I'm going to stash. I'm just doing it because I want to like test it out. Test all the work I've been doing past few streams. Okay, compiled successfully. Let's just do it. Let's just clear everything and then run it. So now initially what's going to happen, it's going to start at a 2.5, not 1.5. So like, again, 7 rows, zeros, 1, 2, 3, 4, 5, 6, 7. But rather than be 0, 1 and be kind of here, it's going to be 1 to right, right? So 2.5 and let's 7.5, let's see how it changes. So now it's going to be, its new X, again, is 1.4, so definitely did not hit the coin. So let's see how it changes. So in 0, 1, so 1, 2, 3, 4, 5, 6 zeros, and then 0, 1. Ah. Okay, yeah, so basically, it used to be here, and it went like up 1 and left 1. So okay, that looks good. The move velocity, the new coin. So like from 2.5, it became 2.5, right? Yeah, 2.5, 7.5 to 1.4. So it shifted a bit to the left, and then it shifted a bit up from 7.5 to 6.4. So okay, so that was basically like. So like we have shown this, we've shown this, we've shown this, and we have just now shown this. We've done 0, 1, 2, 3. So we're like halfway done exactly. We have to do now we have to do 4. So let's do 4. Okay. Go from the top again with 2.5, 7.5. Let's see the new X. The new X is 0.94. So let's and then this one again. We're basically kind of, it's the dual of case move ID with 0. We're straight to right. This is pi radians 180 straight to left. So then 0.09. So let's see what happens. 0, 1. So it should be 7 again because there's no X. There's no X change, or sorry, there's no Y change. So the number of rows don't change. So 1, 2, 3, 4, 5, 6, 7. Correct. And now 1. So basically from here, right, it became here. It shifted to the left, right? Like 1, 2, 3, 4, 5, 6, 7. And like from 0, 0, 1, it becomes like 1, 0, 0. Yeah, like 1, 0, 0. So it shifted there. So we can see that happen. And new locations, like a little bit less, from 2.5 to 0.9. Right? That's good. So like it approximately 1.5-ish change. Okay, so that's consistent. So now we have validated this one. So 0, 1, 2, 3, 4. We have to do 5, 6, and 7. So let's get started on 5. Clear, compile, and run. So this should be quite similar to this one. Like this one here we're doing should be quite similar to that one, except it just kind of goes one row below. That's it. Okay, 2.5, 7.5, good stuff. And then what happens now? Again, these numbers should be really familiar now. The only thing that's changing is their signs. So then, what do we have? What do we have here? 1.4. So like from 2.5, it shifted a bit to the left, which is expected. Same amount of shift as before. Then 8.5. So rather than from 7.5, it went like down by a bit more, like by like one-ish. like, yeah, 7.5 to 8.5-ish, so like it kind of went down by 1, so that's correct. So then what should happen? Prediction should be like, from here, it should be, instead of 7 rows of zeros, it should be 8 rows of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, and 0, 1. It used to be 0, 0, 1. It used to be like here, right, 0, 0, 1, but shifted like down and to left by 1, right? 2, 3, 4, 5, 6, 7, and then like 0, 0, 1. Yeah, 0, 0, 1. So from 0, 0, 1, it becomes 0, 1, 0. So the 1 shift to left and also shifts down by an extra row of zeros. So that means like 1 shift down, 1 shift left. So that is indeed correct. And then the x's, yeah, we already talked about the x's. So this one's done. And now we're almost done. We just have 2 more, 5 and then 6 and 7. So let's do 6. But again, this is very annoying, but like I only have to do it once and then it's like done for good. It's validated. So okay, now from what's the start, 2.5, 7.5 to a 2.5 is the same, but like this should be familiar. We've already done the squared. So now it basically goes down, right? It goes down. Like we're checking the going down, but it should be going down by around 2, right? Or 1.5. So like from here, set 7.5 to 9, right? 7.5 to 9. In the discretized version, we see like from 70001, it should like kind of go down here. So this should be go down 2. So it should be, instead of 7 rows of zeros, there should be 9 rows of zeros and 001, right? 9 rows of zeros and 001. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 001. So the x is the same, but then just 2 zeros. So that's correct. And finally, last one, I can stash or get rid of all these changes and move on. Get status. Like all we have to do is like kind of like destroy these changes, because like in fact we messed up the game state starting, so like we really want to get rid of these changes. And then and because like basically we're just validating these stash changes. I mean, not stashed, staged changes. Yeah, get stash is like kind of, I use get stash as an alternative to get restore if I want to like kind of be like kind of stashed, but not like, or if I'm like switching branches or doing some weird branch stuff, I tend to stash my local changes to avoid conflicts and whatnot. But anyways, last one, right? Last one, 7, and then we're done with all 8 directions. Remember, it's 0 indexed. Clear, TSC, compile it, and run it. Okay. So wait, no, hold on. Prediction, just 1, 1, right? Like one down, 1 right. So from 2.5, so 2.5, 7.5 to what, like to a 3.5, so it's like a little bit down. From 7.5 to 8.5, like 1 to right, so that's good. And then let's kind of like see the location. So then it should be like kind of, so down means 1 row, and then like 001 should be 0001, right? So it's like 1, 2, 3, 8, right? 3, 4, 5, 6, 7, and 8 rows of zeros means it pushed down by 1. And from 001 to 0001, so it's like 1 down and then 1 to right, from 001 to 0001, because 1 extra 0 from the left. So that's 1 down, 1 to right. So that's correct. And then the x's, again, yeah, from 7.5 to 8.5, so it shifted by 1, and then from 2.5 to 3.5, shifted by 1. So that's correct. So yeah, we've now done this one too. So all 8 directions have been done. So then get status, declare, get diff. So this change has to be gotten rid of, because like we're actually like messing up the start state. So that's very bad. Like we don't want all 3 to be there. We don't want them all to line up, right? Like we don't want our game states coins to look like this, where it's like coin, coin, coin. We don't want it to look like, we don't want it to look like 3 coins where like they all line up. We don't want this shape. The shape we want is a bracket shape, right? Like we want this as a starting configuration, 2 obstacles, right? Like we want it to like roughly look like that, where the king is a bit to the back and the coins are a bit advanced. Kind of like the king is sitting on a throne that's a bit kind of like more closer to wall, whereas its flanks are like kind of like the, what do you call it, like kind of like Jedi, like the emperor and like his red guards, right? Emperor or Palpatine and red guard. Yeah, kind of like this. Like, you see that kind of like that thing? Well, in this case, he's in front, but I want him to be behind the red guards. Really, I really like the red guards, royal guards, cool stuff. But anyways, yeah, so we're basically, so I'm just like, so this change has to be kind of reverted, and no need to print it, so we want to get rid of that change. Basically, I'm looking at the git diff so I can kind of restore everything so that we only have what's modified, right? Actually, I mean, I'm going to commit this first, actually. So actually, let me just first commit the changes, because we know that they're correct. So clear, yeah, git status. We've already verified these changes to be committed. So this whatever stage, we can kind of commit right there. So wait, let me see our git diff staged. So basically, we've kind of implemented this function right here. Copy that, and git commit implement net dot this function, which yeah, implement that. Tested. Okay, I should just implement. Tested is like no need. We kind of did tarp. Never mind. So we just commit that. Git status, clear, git status, git diff. So now like we want to kind of discard our changes that we did for testing, but make sure nothing, like we make sure before we just discard our changes, I just want to make sure that like they're only like bullshit changes I can discard just for the testing that we just did. Like there's no other logic that's being discarded. So this thing from 1.5 to 2.5, that is wrong. We want it to go back to 1.5. The only reason I did that is because like when we hit to left, it kind of hit the wall and lost some health. But it was kind of cool like seeing the like this like the form, the structure of like what was printed out, like be the formatting be a bit like damaged because of like the 0.9. Like the length became long, so like forced a new line or something. But anyways, so we want this to start at like, yeah, at 1 at like 1.5 and not 2.5. So that's fine to revert that. We don't want to print the king coin image from the image stack anymore. So let's not print that. And this whole stuff, yeah, let's just delete those because we don't really use them anywhere except for testing. And then yeah, testing out some stuff. So everything below is just the tested out stuff. J to go down. Okay, yeah. So all this stuff, yeah, we just kind of get rid of that. I really, yeah. So that's all. Yeah, we'll just get rid of that. So like, yeah. So it's safe to kind of revert everything. So let's do like git restore all status, and we're ahead by 1. I think I will stop here because we've basically we've basically pretty thoroughly tested this, and we've also as a side effect, we've tested out like, we've tested that function. We've also tested apply move, right? So we've kind of validated our physics too. And we saw the physics also took into account like the damage from hitting the wall too. So that's pretty cool. So that means our physics definitely works. I mean, people have played thousands of games on BumperCoins.io. So like it's very kind of well tested already. So that's kind of nice. Of like hitting, I'm not sure how many games have been played because like ever since switching from game history to game record for replay system, we've kind of like destroyed all the old history in that transition. Because we used to have I used to have a historical like a, no, never mind. The point is, never mind. I'm going off topic. But anyway, so like, what was it doing? So I'm basically stating, I'm just like summarizing like what we've tested. So we have tested like, so we've tested this, we've verified. So what did I do today, right? So what does commit do? So like we've kind of like implemented this function, get move velocity, and this is a helper function, so we can kind of compute that. That's the main goal. So we've kind of like, so by doing this, we should have done that, hopefully. So maybe there's some more testing needed, but yeah, so we've definitely tested this one. And then we've also tested like the apply move too. Cause like if you look at like this stuff, we're actually like, we're actually like doing this line here. So we've actually tested apply move too. And we've kind of like printed out and like witnessed like next game state being different from game state and like these 8 directions for different move IDs. So we've tested out the move class, we've tested out apply move, and then of course we've tested out like our trig stuff in this function right here get move velocity from the move direction. So I think that's sufficient work. It's a good stopping point. Tested it, got to see that existing code works. So I'll just stop now then. 5 o'clock, 5:01. All right, so a lot of screen time. But anyways, let's just kind of stop now.